Good morning, everyone. Sorry I couldn't be there with you today to go through your review, but hopefully this uh, video lesson will suffice. Remember, I will be around tomorrow. You can catch me in the morning. Usually I'm in 318 if you have any last minute questions that you want to ask before period 2 since I'm not here for you today. So today we are reviewing our quadratics, just the part 1, just the first part of this unit for the test tomorrow. So let's get started. We're starting off with factoring. Remember, there was multiple different types of factoring that we talked about. There are 3 key ones that we will talk about. The other ones, remember, are just stuff that you can use in terms of practicing to help make it better. So sometimes it makes it a little bit easier if you can remember the trick, but I'm not requiring you to know how to do those little tricks. Those are just to help you along the way if you can recognize where they come about. So the first one is common factoring. And sometimes when you common factor, sometimes there are 2 terms. It's one of the types that often has 2 terms. So with common factoring, remember that common factoring ends with a term in front of the brackets with all the remaining terms inside the brackets. Remember, all the other types of factoring besides common factoring, they always end with 2 terms inside 2 brackets. This is the only type. Common factoring is the only one that doesn't have that general ending with 2 brackets and 2 terms. So we need to divide out anything that is common between them. So we look for in our equation, what are the biggest common things I can take out? So what's the biggest number I can divide out without going into decimals? And what's the biggest variable, or how many variables can I take out with, again, only taking out the ones that are there? Once you have that, that common factor sits out front. And then what's remaining left inside the brackets is once you actually divide out that common factor. And I just have this reminder here because it's under the 2-term one, is that you can common factor when there are more than 2 terms. So let's take a look at an example. And now your descriptions on the test, they'll only say factor. It won't say what type of factor that you need to do. It'll just tell you that you need to factor. So let's say we have to factor 2xy plus 4x squared minus 8xy squared. So we're asked to factor that. Your first tip in terms of that, the only option to do on this is common factoring, is because it doesn't look like any of our other types of factors. It doesn't have the standard form of ax squared plus bx plus c, so we can't do any of our trinomial factoring. So the only other option we have when it looks like something like this is to do common factoring. So we want to look at what is our common factor that we can pull out of this equation. So we look at our numbers first. The biggest number that we can divide out of each of those is a 2. Then we look at our variables. Which variables can we take out? We see that there's at least one x in each of our terms, so we can take out at least one x. And for our y's, oh, this one's missing a y. Sorry, this one's supposed to have a y here. There we go. And in terms of our y's, again, the biggest amount of y's that we can take out is just one y. So we take out a 2xy. So that goes out front. What follows is brackets. And then remember, inside the brackets, this is where we divide. So we take what is in this original term and divide out our common factor. So 2xy divided by 2xy, because they're exactly the same, anything divided by itself is 1. Then we look at the next one, 4x squared y divided by 2xy. So do it piece by piece. Do the numbers first. Positive 4 divided by positive 2 gives us a positive 2. X squared divided by x. Remember, x squared means that there's 2 x's sitting there, and we're taking one of them out front. So that means that there is 1 left. And then for our y's, we have 1 y sitting here, but we took 1 y out front, so there aren't any more y's left with this term here. So we're just left with 2x. Then let's take a look at our last term here. Negative 8 divided by 2. That gives us a negative 4. Then our x divided by x, again, there's only one x and we're taking it out front, so there aren't any more x's with this term. And then x squared divided by y, again, there's two y's sitting there because it's a squared. We're taking one of them, so there's one y left with that term. And that's it, so we end off our brackets. So this now is our term. This is our final answer here. That has a common factor out front, and then our equation divided out by the common factor as inside of our brackets. So that is our review on common factoring. The next type of factoring that we're going to look at is difference of squares. So remember, there's a couple of conditions that we used to help us determine when there was a difference of squares and when we used this special case. So the first one is that there's only two terms, which is why it's under this heading here of two terms. There's only two terms for difference of squares. So we know right away when there's only two terms, we should be checking for difference of squares. Our second condition is that they're square rootable terms with subtraction in the middle, and that's actually our two other conditions. Square rootable terms, remember, mean that they square root to a nice number, and a subtraction in the middle means that there's that minus in between the two terms. So remember what we do, we square root the first term, and it goes in the first spot. Let's give me a second here. There we go. So the square root of the first term, whatever it is, it goes in the first spot in our brackets. And then the square root of the second term, it goes in our second spot in our brackets. Oops. And then remember, the brackets are the same, except that one gets a positive, so one gets a plus, and one gets a minus. So while you're writing that down, I'm just going to quickly verbally review. So difference of squares, we have two terms. We only ever have two terms when we have difference of squares. Both terms must be square rootable terms, meaning they square root to a nice number, and there must be subtraction in the middle. If it meets all three of those conditions, we know that we use difference of squares. Now we know inside of our two brackets, the square root of the first term goes in the first spot, the square root of the second term goes in the second spot, and then both of our brackets are exactly the same, except one bracket gets a plus and one bracket gets a minus. Now let's look at an example. Again, it still just says factor. We need to decide when we use this difference of squares. It's just going to tell us to factor. So let's say it asks us to factor this. So again, we look, oh, there's only two terms. So let's check for difference of squares. There is a minus in the middle. Now let's make sure that they're both square rootable terms. So we're going to square root the 4x squared. So the square root of 4 is 2. The square root of x squared is x. And then we're also going to square root the second term. So we square root 49. And the square root of 49 is 7. So both of them square rooted nicely, so it means it met all of our conditions because there was two terms, they both square rooted nicely, and there was a minus in the middle. So for our answer, remember we have our two brackets. The square root of the first term goes in the first bracket, goes first in the bracket, so we have 2x, sorry. At the start of each of our brackets. And then the square root of our second term, which in this case is a 7, goes in the second spot in our brackets. And then one bracket gets a plus, and one bracket gets a minus. And there now is our final answer for difference of squares. The next type is when we have three terms. So those were the first two cases. Difference of squares is only with two terms. Common factoring can be two terms, or it's the one that's they look odd. They're not in our typical standard form. Whenever we have three terms, there's always these questions that you can ask yourself that help you know when to use what. So the first one is you always want to ask yourself, because it makes your life much easier, is there a common factor that you can pull out? Remember, pulling out a common factor makes your numbers a lot smaller, so that coming up with your M and A values is a lot easier. So it's good for you to always check to see, is there a common factor that I can take out first to make my life a lot easier? So let's take a look at an example where there is a common factor that makes your life easier. So if we're given negative 5x squared plus 5x plus 60, and we're asked to factor that. If you check first to see if there is a common factor for you to take out, you should notice that actually you can divide a 5 out of every single one of those terms. And actually you can divide out a negative 5 so that there's nothing in front of this x squared after you're done. So your common factor is a negative 5, so it sits out front. And then you can put in the brackets what's left over once you divide them out. So negative 5x squared divided by negative 5 leaves us with just x squared. And then plus 5x divided by negative 5 leaves us with a negative 1x. And 60 divided by negative 5 leaves us with negative 12. Now that we've common factored, we have a much easier trinomial inside of our brackets to deal with, because we no longer have a number in front of the x squared, and our numbers are so much smaller, which makes it a lot easier to come up with our m and our a. So if you can remember, always ask yourself, is there a common factor I can pull out first? The second step then is to determine, is there a number in front of your x squared variable? Because remember, that determines whether we can go the easy route or whether we have to go into the harder route. So question number 2, is there a number in front of our squared variable, which is our x squared? If yes, if there is a number in front of our squared variable, we have to go into decomposition, which is step number 3. If not, remember, that's when we can use factor by inspection. And remember, factor by inspection is where we come up with our m and our a, and our two numbers that work, that multiply to the m and add to the a, and we can plug them directly into the brackets. Plug two numbers directly into the brackets. So we don't even have to do any other steps. Once we have the two numbers, we just plug them into the brackets and we're done. So if you can recognize when we have no number in front of that x squared, remember that's one of those steps that saves you some trial, saves you some steps. So in that case, if we look at our previous example up here, once we common factored out that negative 5, what's left inside of this bracket, it doesn't have a number in front of that x squared, so we can do factor by inspection for that one. So let's continue on with the previous example. So there is no number in front of that x squared anymore since we factored it out. So let's pull out our m and our a. Remember, m is the first number multiplied by the last number But in this case, because the first number, there's nothing there, it's technically a 1. It's 1 times by negative 12. So our m value is just negative 12. Our a value, remember, is always the term that's in the middle with the single x. So in this case, just a negative 1. So we need two numbers that multiply to negative 12, but add to negative 1. And our two numbers happen to be 3 and negative 4. And remember, if you struggle to come up with those two numbers, write a list of all the different things that multiply to 12 and see which combination is the one that adds up to your add number. Now that we have our two numbers, and because it's inspection, because there's nothing sitting in front of that x squared, we can jump into our two brackets. And remember, with inspection, x is always the first piece in both of our brackets, and then our numbers follow suit. So x, our first term is a positive 3, so we do x plus 3. And in our second bracket, our second number is a negative 4, so we have x minus 4. And that now is our final answer for when we have inspection. The last case, just going to bring this up a little bit. Oops. That didn't work very well, did it? Well, we'll just have to leave it where it is then. Sorry about that. Our last case is number 3, where we use decomposition to factor. So this is where, in this step here, when we ask the question, is there a number in front of the squared term? If we answered yes, then we have to go to step number 3 and use decomposition. So then remember, with decomposition, we have a couple different steps with that one, but it starts the same as inspection, where we use our m and our a values. So let's just take in another example here, since our last example was one that we used inspection. So this time we're going to factor 2x squared minus 5x minus 12. Oops. There we go. So in this case, we can't common factor anything out to make it simpler. The only thing we can do is move into decomposition, and we know that we have to use decomposition because there's this 2 sitting in front of this x squared, and there's no way to get rid of it. So we have to pull out our m value and our a value. Remember, the only difference with the m value and a value is that our m value makes up the a multiplied by the c, so the first number multiplied by the last number. So we have to do 2 times negative 12 to find our m value. So in this case, our m value is negative 24. But our a value is still just this middle value of negative 5, because that's the one sitting in front of the x. So we need to come up with our two numbers that multiply to negative 24, but add to negative 5. So again, if you're struggling with that, go through all the different options of things that multiply to 24, and then find which is the pair that then adds to negative 5 when you have a negative in one of those numbers. In this case, the numbers that work are 3 and negative 8. Now that we have our two numbers, remember, with decomposition, this is where we go back to our original equation and we decompose or break up our middle term into the two numbers that we came up with. So in this case here, we have 2x squared. And then we're going to put in our two numbers. So let's do negative 8x plus 3x. And then our last number here is the negative 12 from the top. And again, that's from the original equation up here. So we broke up our negative 5x into the two terms of negative 8x plus 3x. Now then, remember, at this point, This is where we break our equation in half and do some common factoring between our two terms. So now that we've broken up our equation into two different pieces, let's common factor out of each piece. So we look at our first piece here, and we have to find the greatest common factor out of a 2x squared minus 8x. So the biggest number we can factor out is a 2, and because they both have an x, we can also factor out an x. Then remember, we put our bracket and we take these first two terms and we divide out our common factors. So we do 2x squared divided by 2x, which leaves us with just an x, and negative 8x divided by 2x leaves us with a negative 4. Then we look at our second half here and say, okay, what is the biggest thing that we can factor out of both of these? The biggest thing we can factor out is a positive 3. So we write plus 3, and then again we throw another bracket. And then inside that bracket, that's what's left over once we divide out that 3. So 3x divided by 3 is just x, and negative 12 divided by 3 is negative 4. Remember, at this point, this is where we can do our little check, because if we've done it correct up to this point, both brackets after we common factored should be the same, which in this case they are. They're both an x minus 4. If they're not both the same, remember that's your indication that we've made a mistake and that you have to go back and check your calculations. One other thing that I wanted to remind you to point out is, remember, once you take your two numbers and put them in here, it doesn't matter what order I put them in. I could have put the 3 first and then the 8. I still would have ended up with the same answer in the end. I just would have had slightly different common factors, but it still would have worked out. So that's still an opportunity. Don't forget, it doesn't matter what order you put those two in. Now let's look back here. We have one more step because remember, our final answer has to be in two separate brackets. So at this step here, because both of our brackets are the same, we can take that bracket and put it out front and common factor it out of both of these terms. And then remember, whatever is left over after we take out these two brackets makes up our second bracket. So the first is the 2x, and then the second is the plus 3. So now, because our answer is in our two brackets, this is our final answer for our decomposition example. At this time, if anyone still needs to copy this down, please pause the video. I'm going to move on to the next example. So the other thing that we use factoring for, besides just factoring, was, remember, we use factoring when we're asked to find the x-intercepts, or we're asked to solve. And remember, when we're asked to solve, that just means they want us to find the x-intercepts. So remember, these are our steps to be able to solve our equations. Is we set our equation equal to 0. That often means that we're setting y equal to 0, because to find an x-intercept, remember, that means that y has to equal 0. Once we've set it equal to 0, then we factor using one of our factoring strategies that we just talked about. Once we're finished factoring, we set each bracket equal to 0, and then we solve for x in both of our cases. So let's quickly take a look at an example. We'll just use the example that we just factored. So our final answer for that one was x minus the brackets x minus 4 and 2x plus 3. So in terms of our example, it would have asked you maybe just to solve, and it would have given us this equation here, our 2x squared minus 5x minus 12. Would have asked us to solve that. Our first step would have been to take that and set it equal to 0. And then we would have factored. So I'm just going to put ... factored previously, because we've just factored that equation. And we know that it's the bracket x minus 4 times the bracket 2x plus 3. So that's now all set equal to 0. And then we take each of our brackets and set them equal to 0. So we get the bracket x minus 4 equal to 0. And we also get the bracket 2x plus 3, oops, there we go, equal to 0. And then we just need to solve for x in both cases. So on our first one here, we take our -4, bring it to the other side of the equation, so it becomes positive. So our first answer is that x is equal to 4. For this one, we take this +3 and bring it to the other side of the equal sign, so it becomes negative. So we have 2x is equal to -3. And then our last step is to divide both sides by -2, or both sides by 2, sorry. So that on this side, the 2's cancel out, and on this side, we have x is equal to -3/2. And those are our two answers, and those would be our two x-intercepts in this case. Something else that we've looked at in this unit that we talked about yesterday was completing the square. Remember, we complete the square to put an equation into vertex form. And remember, our general vertex form is y equals a x minus h all squared plus k. Oops. Remember, this is our general vertex form, and we want the equation to be in that vertex form. Typically, when we're asked to complete the square, or in situations where we have to complete the square, we're given the equation in standard form. And remember, that's where it's in the form of ax squared plus bx plus c, which is the ones that we were factoring. But we want it in vertex form to complete the square. Once we've put it into vertex form, by completing the square, we can pull out our vertex, which remember is just the h. The sign has to change. So if it's a negative inside the brackets, it becomes a positive outside the brackets, and vice versa. And then our second letter, our y value, is always the k value. And the sign stays the same since it's not inside brackets. And remember, your key words that I'm really stressed yesterday for you guys to memorize is your key words are minimum and maximum. If you ever see, remember, if you ever see the word minimum or maximum, especially in a word problem, you always have to find the vertex by completing the square. And remember, it's always asking for the y value of the vertex in that case when it asks for the minimum or maximum value. So let's quickly take a look at an example of completing the square. So in this case, we're going to find the maximum value. Okay, so our example is going to be y is equal to 4x squared minus 16x minus 2. And again, we're asked to find the maximum value, so we know we have to, 1, complete the square. Once we've completed the square, we can find the vertex. And once we found the vertex, we can pull out the y value, which is our maximum value. So remember, our first step in completing the square is to factor out the a term, so whatever is sitting in front of that x squared term out of the first two terms. So we have a 4, and then we divide it out. So 4x squared divided by 4 is just x squared. Negative 16x divided by 4 is negative 4x. And then this minus 2 at the end, it just trails on behind after the bracket. Okay, so now our second step is, remember to take the term in front of the x, which is the negative 4. Oops, there we go. Divide it by 2, and then square it. So negative 4 divided by 2 gives us a negative 2. and then we have to square it, and negative 2 squared is 4. Now that we've squared it, remember this is the 4 that we need here, and we take that number, and inside of our brackets, we add and subtract that number. So we do plus 4, and we do minus 4. And remember, the plus always has to come first whenever we do that. Plus first, then minus. And then our negative 2 still trails at the end after the bracket. Now remember, our next step is to take our 3 terms inside of our bracket, our first 3 terms here inside of our bracket, and we replace them with a squared bracket. Because remember, we're technically factoring those 3 terms into a squared bracket. And remember, that's a squared bracket because technically it makes a perfect squared for us. So all our other terms still stay there. The only ones that disappear are the first three terms that make up the perfect square. And then inside of our squared brackets, remember, we always start off with an x. And then our second term inside of that brackets, remember, always comes from this term up here, when we divided, but before we squared. So in this case, it's a negative 2. So inside our bracket, we do minus 2. Now that we have that, remember our next step is we have to get rid of these extra brackets that are here on the outside because our vertex form doesn't have that extra brackets. It only has brackets around the squared term. So remember, to do that is we take our a value here, it gets sit in front of those brackets, those squared brackets, and it also gets multiplied by that second term inside those brackets. So we then get 4 bracket x minus 2 squared. And then we do 4 multiplied by negative 4, which gives us a negative 16. And then we still have this minus 2 at the end. And then our last step is just to collect our 2 like terms at the end so that we only have one number trailing at the end of our equation, which makes up our k value, which in this case is negative 18. So now it's in the vertex form. And we can pull out our vertex. So remember, the vertex is our h value, so inside the brackets, but remember, anything that's inside brackets, when we pull it out, the sign changes, so it actually becomes a positive 2. And then our last number at the end, which is negative 18. Now that we have our vertex, the question, remember, was asking us for the maximum value. And remember, the maximum and minimum value is always the y value. And in this case, our maximum value is negative 18. And I just realized I goofed a little bit on this question, but it's a really quick and easy fix-up. Is for this equation, it's not actually a maximum value, it's going to be a minimum because our a value is positive. Because our a value is positive, remember, that tells us that our parabola opens up. And when a parabola opens up, our vertex is the lowest point, so it's actually a minimum. So let's just adjust that one here. Sorry about that, guys. It's a quick adjustment. It's actually the minimum value that we were finding. So it's actually the minimum value is 18. It's not a maximum value. Sorry about that. But if I made a mistake like that and you answered the question correctly, that would be fine. You wouldn't lose marks because that was my fault, not yours. If anyone still needs time to write this down, pause the video. I'm going to move on to the next section. Our next section is our last big section, is graphing quadratics using our 4 points method. And remember, that was when it's given to us in not standard form, we did it in vertex form. So remember our vertex from vertex form, we get that by pulling out our value of the vertex. So that's pulling out our h and k value from vertex form. Our x-intercepts, remember that's when it's in this vertex form where we set y equal to 0 and we rearrange and solve for x. And remember, when we're rearranging and solve for x, there's a case where we have to square root both sides. And remember, whenever we square root both sides, we got to add that plus minus in front of that square root, because remember, it could be a plus or a minus. And that's where you get your two different answers for your x-intercepts. And then our last one is our y-intercept. And for our y-intercept, remember, that's just where we set x equal to 0 and we solve for y. And to solve for y, we just follow our basic BEDMAS rules of doing inside the bracket first, then our exponent, then our multiplication, and then our adding or subtracting. Just one thing to remember with graphing your quadratics is that you remember to label your axes, so make sure you're labeling your numbers on your graph, and then you're also labeling your axes in terms of y and x. Also, don't forget to label your equation once you've drawn it out and plotted your points, because those are all your communication marks. Our last thing was word problems. Remember, with word problems, and we already talked a little bit about this, you have your keywords of maximum and minimum. Remember, whenever it tells you to find the maximum or minimum, you need the vertex. So you need to find the vertex. And remember, to find the vertex, you have to often complete the square if it's not already in the vertex form. If there's ever a case where we have to find the x term of an equation, usually it's asking us to find the time. And remember, that means finding your x-intercepts, and that's just rearranging so that the equation is set equal to 0 and solving for your x values, just like we have seen before when we rearranged or when we were factoring. One thing that really helps with word problems is sketching a diagram. So depending on what type of example you're looking at, if you sketch a little diagram, it often will give you a logical idea about what the problem looks like or what the situation looks like, so that you know what you're looking for. And that's a great thing to help you when you're stuck, if you're trying to figure out, okay, what exactly is they asking me to solve for? Draw a diagram and see what logically makes sense. So with the remaining class time, you have a review package that will be handed out. Remember, your review package is a good indication of the types of questions that you'll see on your test tomorrow. There are solutions on the back, but it's just the final answer. It's not the full solution. That's just so that you can check to make sure you got the right answer. So please use that to your advantage. It's a great way for you to make sure that you did do it correctly, to check to make sure that you have the right answer. Again, if you have any last minute questions and you want to come find me tomorrow before class starts, I'm usually at school by 8:30. You can come find me and you can ask me questions at that point. And again, I'm usually in room 318, which is just 2 rooms down from this room. Otherwise, have a great day and use your class time wisely to get working on that review package.